when you see something like that, let me make sure I got the integer limits. I told you those are integrand limits, right? Limits of integration. This is our function. Okay, so all this is saying, like if you were to verbalize this, it would be calculate the area between the curve and the x-axis from 0 to 5. Okay. Kind of like what we've been estimating, right? Now we're going to do it in exact manner.
So that's what that means? Or that's
Yeah, this is verbal, that's algebraic written out statement. Okay. All right, so this is a linear equation, right? Y-intercept is 3. The x values are 0 to 5. There's our function, if you graph it.
Where do you get the 2 from?
If you want to find where x is 5, 3 minus 5 is negative 2. Right. Didn't put a negative there. So geometrically, you're looking at the area of that triangle and the area of that triangle, right? So this is one half.
3 times 10.
Yeah, 3 times 3, right?
Right. So 4.
What's the other one? Two? Okay. Here's what you have to be careful about when you calculate area. This is what we call signed area. Okay, so anything above the x-axis is positive. What do you think anything below the x-axis is? Negative. Yeah. So it's a position thing again, right? Like velocity, negative and positive are direction indicators.
Right.
Well, this is just position. Where is the signed area? It's not, so we're below x-axis, it's a negative, okay?
So that would make that a negative, right?
Yeah. So the area of this right here, so what I should probably write, the integral from 0 to 5 of 3 minus x dx equals
4.5.
4.5
Yeah.
minus 2, which is 2.5.
Why would you calculate the area of that triangle instead of calculating the area of that trapezoid?
What trapezoid?
So like if you draw the line from -2 across the 5, and it's, I don't know, yeah, right there, yeah.
Okay, this is the line, right? 3 minus x.
Right.
This is not between it and the x-axis. It is completely between that line and the x-axis.
Okay.
So if you were looking for y-axis, okay, Brad, so
You can integrate along the y-axis, and that would be a trapezoid.
Yeah.
But
Okay, well, no, I just wanted to show you. Oh,
Yeah.
it does say between the curve and the x-axis.
X-axis.
Yeah.
These are,
What are the 2.5?
see that X right there? That means between curve and X-axis.
Oh, yeah.
Right. Okay.
So if it was a Y, you do it with the Y axis.
Right.
And they do that.
Oh, you can pick my
Very rare. Okay, we can, so you can, if you know this is a line, something that gives you like a rectangle or a triangle or something, you can, or a circle. I think there's a circle on the homework.
Oh.
No.
Pi r squared, right?
Yeah.
You can do the geometric calculation of the area. Okay? You can also do it algebraically. Because you know antiderivatives, this is not, oops, a big step for you. What is the antiderivative of 3?
0.
No, that's the derivative. 3x.
Over so
The derivative of x
x
is,
over 3. X squared over 2.
remember, add 1 to the exponent and divide by that.
Are we wrong when we say, for whatever reason, I keep putting it in fractions? Is that wrong? Because 1/2 times 2 is 1. Create that.
1/2 of x squared is fine.
Okay.
It's the same thing. Okay, now here's what you haven't learned yet. This is called a definite integral. This is called evaluate from 0 to 5.
Do we need to find plus?
And this is how you write it. Okay, so once you've calculated the antiderivative, the integral sign's gone, and now you write evaluate 0 to 5. Okay, no, that's the nice thing about what we're doing now. Since there are numbers here, the plus c's gone.
That's what Y equals was talking
Okay.
about.
Yeah, so this is called, the plus c is an indefinite integral, no numbers,
But
so we have to put plus c. Now we have a definite integral, we don't need plus c. Now, here's the step you haven't learned, evaluate. So plug 5 in. Minus, plug 0 in.
Did you do it the other way or did it not?
You don't want to because it's subtraction.
Oh, okay.
It will be
Painful.
the wrong answer. Yeah, so plug the top number in, minus plug the bottom number in. And then simplify. That's a minus.
What's the number on top of the isn't it just going to be whatever the first?
3 times 5 minus 5 squared over 2.
What?
Okay.
And then minus 3 times 0 minus 0 squared over 2.
So whatever.
3.5.
I'm going to go with 2.5. Saying that that's what we got when we grabbed
No,
it.
yeah.
You just didn't calculate it right.
Because I can add and subtract.
Okay, same answer.
Simple math.
Yeah, same answer.
So if like, would they ever ask for units or is it just going to be just a number?
We aren't given any at this point. We could, but we'll get to that. Most of the time, when you're asked for units, it's we'll get to it.
Okay.
16 minus 12.5.
He's just like, yeah.
It's a rate problem, and then you integrate a rate problem, and you get total distance change. So
And it's painful.
it goes from meters per second to say your answer's in meters.
Oh.
That's all you have to do.
I can't apparently do simple division. 25 divided by 2 is 14.5.
Do you want me to do another algebraic on the right?
Yes, please.
Okay.
Which one, does it just matter on what the situation is, which is easier?
Okay, so does this form a nice geometric shape?
No.
No, it's a curve. We cannot geometrically solve this problem without approximating it with a Riemann sum or something.
Is that a, oh.
But, so we have to do this one algebraically.
Is it 4? Okay.
4 to 7. So you don't need, again, you don't need to do this, but this is the area you're calculating, right? That's x squared. That's what we're looking at. So, what is the antiderivative of x squared?
Over 3.
Evaluated from 4 to 7. No. Top down, top minus bottom. 7. Yeah, so you have 7 cubed minus 4 cubed over 3. No, if you switch these, you'll get the wrong answer because it's subtraction. Subtraction is not commutative.
Right.
You'll get the negative of the answer. It's not right. Okay, does anybody know 7 cubed?
No.
343. Come on, folks.
49 times 7. Go.
That one?
64.
Thank you. That would hope you know. 7. And then
Because everyone uses 7 all the time.
7 cubed.
39 minus 64, 2. 79?
Sure. We'll go with that.
What do you think?
Is that right?
Sounds right. Looks right.
Yeah, it is. And then that's actually divisible by 3 if you so inclined.
Do you have
79, so 93. Yep.
Yeah.
Wow. That's
So
impressive,
if,
David.
so we, okay, if this is like a free response column, could you leave it?
That is a perfect answer right there.
Okay, so you don't have to.
Free response answer right there.
Okay.
In class answer right there.
So that's both perfect in class and the response.
Okay. Good. And then
But then a multiple choice answer might stop anywhere along that path of.
Watch that be broken.
it would probably be here. Okay, one more.
Get all out of everyone's grill, bruh.
Ah.
Oh, circles, gone.
Yeah, so again, you're going to have to do trig. Trig
Really?
functions.
I love trig. It makes me happy. I say it in the trig.
Anybody have a guess what the answer is?
7.
Wrong.
Hi.
Like overall or the derivative?
Okay.
Root 4 over 2.
What's the antiderivative of sine?
No.
Negative sign.
Negative?
Sign.
Cosine. Again, derivative of cosine is negative sine, right? There's no negative here, so you have to. You can again
Wait.
continue to think in those modes.
Is it 0?
So it turns into
0.
Okay. Cosine at 3 pi over 2 and cosine at pi over 2.
0.
It's going to be negative root 2 over 2.
Nope, 3 pi over 2 cosine 0, which negative 0 doesn't make any sense, but at pi over 2 cosine 0 again, so you just get 0. Evaluating trig functions, get the unit circle in your melons. Graphically,
that does not work.
it works. Yeah.
Oh.
That is good for.
Here's the sine curve, right?
Yeah.
Pi over 2 to 3 pi over 2.
Negative 0.
Oh.
Right? They cancel each other out.
Yeah. I see.
So what was the application of this?
But we'll get to that,
Bridges.
Montaigne. Right now, we're just taking baby steps.
Is it bridges?
The Golden Gate Bridge.
So, will it specifically ask you to solve it graphically or algebraically, or is that your plan?
Some of the problems say solve 2 ways,
Okay, so you have to show both ways.
but this one we can't.
Yeah.
But yeah, if it's a geometric, it'll be a circle or a triangle or something.
So like if it asks you show two ways, can you like do the algebra but then just kind of make the graph like that? Or do you have to like show what
You would show the calculations for area, but.
How about you need to go and save it? And is this what we're going to use on the roller coaster with the engineers?
Oh yeah, we have that. Trick
Oh,
one.
that,
We're doing that? Okay.
Is there 11B?
yeah.
That's like probably working.
Yep, okay. Do
That's it?
tomorrow.
Actually, I think she's a tour guide.
You don't have, not a lot of work.
What does that say?
Yeah.
Not
so
11A.
It's not during the school year. It's like around the time we get out.
I was hoping to give you more work time, but that swelling finger kind of put us in a pinch.
A little bit.
I've been sitting on that one this entire
No, I
time.
haven't, actually, I just thought of it.
I don't know if we believe you.
So,
Because it was pinching off the blood
That was-
pressure.
okay. Yeah, I know, I'm funny. Trust me.
Not 11A. Okay.
Say it's 11A.
Yeah, what